AND gate. So we are on BlockSim, fault tree diagram, right click, and instead of creating this time an analytical fault tree, we create a simulation fault tree. So we use the second interface. So we click OK, and we still got a blank piece of paper on which to develop our fault tree, but we just sort of rename this, and this is the AND gate. Okay, so we have exactly the same interface, but we notice here we got different symbols. We don't have any more the calculation, but we have a simulation, and we got an S to indicate we are on a simulation interface. So we're going to insert an AND gate, and below which we put in two events. So our AND gate, we call it simply AND, and the description is thermal overloading, and we click OK. And the event, for simplicity we're going to call it A, and is overheating. Okay, and the second event is obviously B, and is thermal relief valve failure. And we click OK. Okay, we just rearrange them, and now, like we did before, we're going to assign functions. So we say we assign the model A to the block A, and we click OK, and we assign the model B to the block, or to the event B. Okay, so we have a simple fault tree made out of an AND gate, below which we have two base events. So now we can simulate, and we noticed, before we simulate, we noticed that the time, or the scale parameter is 2200 here and 1000 here. So we've got to be careful if we want to have a full behavior of our model. We have to simulate at a time that is obviously goes well beyond the scale parameter. So as a sort of rule of thumb, we can say simulate at 3 times. Say for example, yeah, about 6,500 hours. Okay, so then we'll present results every 10 hours, but we don't look at this aspect. We're going to simulate 1,000 times in a time window 0 to 6,500 hours, and we click OK. So here we got some information we haven't seen, but this is the mean availability, and what we are interested is in the behavior of our fault tree. So we have a lot of diagrams to explore, but there are things that we haven't seen. So we go instead on the blocks up and down. Okay, and here we see the behavior of our fault tree. So we change some of the colors a second to make it a little bit more vivid. Okay, and that's a 3. And this we're going to make them also 3, where we're going to make them red. And so this one here. So if we just look at the diagram, say at 3,000 hours, so we cut the results at 3,000 hours, just to view it better. Okay, we can see that block A has failed after roughly 1,200 hours, 1204 precise. Does not get repaired, there's no repair action, so this is out of action. And then the second block fails at 2,554, and that leads to a failure of our system. Okay, so the fault tree, we can, if we go back to analytical format, this is, we got the results at, say for example, 2,500 hours. So the results are 0.98 and 0.71, and the actual formula for the OR gate, for the AND gate in this case, it's simply A times B. And in fact, we can see the results. 0.98 multiplied by 0.71 gives us 0.7. And that's it.